All right, I want to spend a minute reviewing how you create relationships in ASP.NET Core using the model first approach, where you do the code first and generate the database from that. The Contoso database does that, but that's kind of big. So we're going to look at a couple examples that are a little bit smaller, and maybe that will make some of the concepts a little clearer. I just posted these links today, and there's no screen on. Just posted these links today. And this one shows one-to-many relationships. There's also links to other kinds of relationships on the bottom of this article. So let's look at it. All right, and they're talking about having two tables. Order and order item. And it's such that an order can have multiple order items, but each order item is associated with one and only one order. So this is how it would look like if you did it like in Excel or something like that, if you did an Excel worksheet. And this is sort of how the database table would look too. The foreign key here is from order ID in the order item table, pointing to the ID in the order table. Now, by convention, if you set it up this way, you'll be okay. Remember, this is let me see if I can do this. I was hoping I could write on this. Relationship between order and order item is one-to-many. That is, one order can have many order items, and a given order item is only for one order. So let's look at how we implement that. On the many side, where we have order item, an order item points to only one order. So therefore, what we're going to have is we're going to have a single order ID. That's going to end up being the foreign key in database terms. And we have an order object that we can get filled. And we can fill that so that we can find information about the order associated with that item. So this is the many side. This would be a one-to-many relationship here. Now, on the order side, we have multiple order items, and in the way that we say that is by saying that we have a collection or a list of order items. So in this case, this is what we have: a collection of order items associated with that order, because one order might have multiple order items, but a single order item has only one order. So we have an attribute. This is sometimes called a navigation property because it helps you navigate to the order. And then we have the order object itself so that we can easily get a reference to the different attributes on that order that is associated with that order item. So that's how I want you to do classes like this when there's a relationship. Now, on the bottom, they show some other slightly different aspects about this. They show annotations you can put on here. They also show what's called a shadow property. In other words, if you look at this, they have omitted the order ID from the order item. You can do that, and the ASP.NET Core is smart enough to figure it out, but I would not do that. And in fact, what the framework will do is it will create an order ID number in the order item. but I wouldn't do it that way. A couple other examples they have, how to implement one-on-one relations. I think we saw this in the Contasso database, but essentially we do this. We have associated with the employee, we have an employee's details class, and associated with the employee details class, we have an employee object. And we have an employee ID. And that will be smart enough to tell the framework, or the framework will be smart enough to understand that that implements a one-to-many relationship. Finally, the many-to-many relationship we can do two different ways. And I'll do that by showing you in the Contasso example, because they have both ways of implementing a many-to-many relationship in that example. So let's look at that, and let's look at the models for between instructor and courses. This is one way of implementing a many-to-many relationship. And in this way, what we have is in the courses entity, we have a list of instructors. And in the instructor entity, we have a list of courses. Now, so there's many going in both directions. So this is a many-to-many. Now, this is an example of a many-to-many relationship where the only thing we need to capture is the fact that there's a relationship between those two entities. We don't have any attributes associated with that relationship. So therefore, it's enough to have a list of each of them in the other one. So a list of courses in the instructor, a list of instructors in the courses. And ASP.NET Core, when it creates a database, when you update the database, will be smart enough to create an intersecting entity that has those two attributes in it, and only those two attributes. Now, the relationship between student and courses, you might think is the same, but it's a little bit different because there's an attribute for the student course relationship, and that is the grade for the course. So there's an additional piece of information that can either be stored in the course entity or in the student entity, right? Because a student's grade depends both on what student you're talking about and what course you're talking about. So we do those kinds of many-to-many relationships by creating an intersecting entity where we have an enrollment entity that has an enrollment ID, has a course and ID and student ID, has a course object and student object. And then both the student and the course have a list of enrollment objects. Because one student may have a list of courses that they're enrolled in, a list of enrollments that they're involved in, and a course will also have a list of students that are enrolled in that course. This is key to getting it right, to getting these things right. If you don't get this right, a lot of bad things will happen. You'll run into difficulty. Therefore, my suggestion to you is as you go and work on the assignment, is when you think you have, and pardon me because I don't quite remember what's due when. Yeah, the assignment that's due Wednesday, you'll be creating a meals and category. And you need to implement the relationships between the entities using the foreign key and the navigation property. Okay, in order for that to work, you need to get the models correct, right? Therefore, if you want, before you go ahead and do the scaffolding and creating the two scaffolded sets of pages, If you want to, feel free to email it to me and say, this is what I have for the two models, and are they correct or not? It definitely will be a big thing when you get into the project design, because in the project design, getting the entities and the relationship between the entities correct and getting those models correct is a big part of the job of getting the project correct. It would be the equivalent of, in the old days, getting the database ERD correct. All right, because you need to know the entities that are involved, you need to know the relationships between them, and you need to make sure that those things are connected correctly. So for your project as well, one of the things that you have to do is in the design portion of it is your list of your entities. At least 4 entities with a description of what the entities are, what the entities contain, and how the entities are related to each other. My suggestion for you, and this is not a requirement, you could just write it out in Word, but my suggestion for you would be to actually create the entity classes, that is the models for the different entities within your application, and just copy and paste that into Word for me to look at. That way, you'll be, you have a step forward, a step ahead in solving the whole project when you get to that point. Right. Oh, I stand corrected. It will show the model classes for each of the entities, including the relationships. I thought I had that as a requirement. So you'll turn in the ASP project that has the model classes created for the entities in your project. Now this is due in a couple weeks. It's not due Wednesday. It's not due a week from Wednesday, but it's due 2 weeks from this coming Wednesday. So it's not too early to start thinking about it. You have, now that we've covered and you have a basic understanding of the relationship between entities, you should be in a position to create the design of it and the prototype that's due on April 3rd. We're going to learn some more stuff. We're going to learn some link queries, and we're going to look at different ways to do things and so on. But that's icing on the cake. Most of the core of the application that you'll create, we have covered. While I'm on the topic of the project, the one thing that I want to emphasize is the need to make meaningful queries. All right. What do I mean by meaningful queries? Well, a list of customers isn't necessarily terribly meaningful. That doesn't take and that doesn't combine information to give you something that you can act upon. All right. This goes back to the whole thing that you probably have had in some class somewhere, maybe your database class if you've ever had one of those. But the whole difference between data and information. With data being the raw facts. And we do some kind of processing to that data to create information. And information takes those raw facts and organizes them, summarizes, filters, combines, and any number of other things. That's how we get information from data. The example I give in a lot of my classes, if you said that a organization had $30,000 sales last year, is that good or bad? Well, it depends on the organization, right? It depends. If that was, say, a little t-shirt business that I was running on my garage, if I did $30,000 last year, I'm probably pretty happy. All right. If we're talking about a major corporation with hundreds of thousands of dollars, $30,000 revenue would not be really that big of a deal. That probably would be a problem. So how do we understand if that raw fact is meaningful or not? We compare it. Maybe we compare the sales amount with what we sold the previous year. You know, $30,000 is good, but not if we sold $35,000 in the year before. But if we sold $20,000 the year before, then $30,000 is pretty good. All right. We would compare it with our expenses. We could combine it with our expenses and look to see, you know, hey, if we got $30,000 of revenue, if our expenses are only $20,000, hey, that means we made a profit. If our expenses are $40,000, then hey, we had a loss and things aren't so great. So the way you transform these raw facts is by combining, organizing, summarizing, and filtering out them. And that's exactly what queries do. So I encourage you to think beyond the box of just creating these scaffolded things where you can get a list of members of the entity, you can add, change, delete. You know, if you do that for all your entities, that's a good start, but that's not a completed project. The project should have things that combine things in a meaningful way. And what do I mean by meaningful way? I mean something that you can take and do something with it. All right. For example, later on in this class, we're going to make course rosters. All right. So at least in the old days, you know, you would get a paper printout of the students that you're in your class. Nowadays, we don't get that anymore, thank goodness. What we get, if I log into Canvas, I see a list of the course roster. So I see all the students that are enrolled in a particular class. So there's nothing currently in the Contusso application that gives me a listing of the roster in a nice form that maybe I could use if I was a teacher teaching a course. But organizing it that way and showing all the students for a particular course that's sorted in a nice order and so on would be a way of taking something that's useful, something that someone could do their job with. All right. Exception processing is a way that you can filter out stuff to show something that's meaningful. Are we, you know, if we were the credit manager, let's say let me rephrase that. If we're the collections manager of a company and our job is to collect debt that's due to our organization, we don't want to see a list of all our customers. We want to see a list of customers that owe us money. In fact, we might not even want to see a list of customers that owe us money. We might want to see a list of customers that owe us above a certain amount. So, you know, if someone owes us $5, we're not going to worry about it. If someone owes us $10,000, we're going to worry about it. And we're going to put our efforts to collecting that money. So all these ways are techniques. We can take that raw data and transform it into something that someone can use in actually performing our job. And that's what I want you to really think about when you do this application, when you do your project. I'm taking a little diversion here to talk about the project, but I think that's important. Think beyond just the straight listing, add, change, delete, view. What can you do to add queries that will give some meaningful information out from the data that you're recording? All right, anyhow, getting back to where we were, the two ways of doing a many-to-many. One is that you actually create an entity for the intersecting entity. That's actually when you have, you can do that really in either case, but you definitely would want to do that if there's properties. Like in this case, enrollment is the intersection between courses and students. And we create a separate entity because we have a grade attribute that we want to store. That is the grade for that student in that particular course. We don't need to create an entity for the intersection between instructor and course, because there's no piece of data that we store with that relationship. Now, I could have created an entity for that, but you don't absolutely have to. All right. Next thing I want to look at is I want to show, I think we looked at this, but it's been a couple weeks. So I want to show how we can pull data from one of these other tables or from a related table or related entity, and how we can create a drop down for something. And we'll do that by looking at department. And we'll look at the department create and the department index. So if I go and run this, if I go to departments, remember each department has an administrator, and that administrator is a faculty member. So the relationship between department and administrator is one to many. One department has one administrator. One administrator could be the administrator of several departments if we wanted to. All right, so here we have, and we show that administrator. That administrator name is not in the department. What's in the department? The department ID. The name, that's the name of the department, not the name of the administrator. A budget, I think, start date. And there's an instructor ID and an administrator, a class that we call it, or an object that we call administrator, which is of type instructor. So that's where we get the name of the administrator, is through this property here, which we have this navigation property that will allow us to fill in this object when we retrieve data related to the departments. We'll take a look at how that happens. We'll also take a look at when you enter a new thing. So let's enter a department CISS, budget, 20 million, let's say, start date, today, why not? An instructor. We can go in and we can select the instructor for this. Now, there's a few things I don't like about this. All right. One thing I don't like about it is that it defaults to the top instructor on the list. All right. That probably shouldn't happen, because if I wasn't paying attention, I could just click create and not realize that I assign this department to that particular administrator. I would prefer to have a blank line in front of it for like something that says, please select administrator from this list. The other thing I don't like about it is it displays the first name. Gee, we better hope there's only one Roger, and actually there's two Rogers. So I picked that Roger. Which one am I getting? Look at the list of instructors. There's actually two Rogers. So that's not too good. So we're going to fix that as we go in and look at this example. We're going to fix another thing about it too, is it passes the data from the model to the page in sort of a goofy way. Yes?
It is realistic. I mean, of course, there could be two structures that's named Roger.
Right. That's not the part that I'm saying we're going to fix. We're not going to put a policy in saying that, like, oh, sorry, we can't hire you. We already got a Roger. You know, What we're going to do is we're going to make the dropdown better so that when we click on the dropdown to create a new one, instead of seeing their first name, we're going to see their full name. Right? I suppose even that could be a problem, right? If you could have two John Smiths or some very common name, but we're not going to worry about that one today. We're gonna just say, hey, we give the first name and last name. All right, so let's look at how we create a dropdown on that create page. Oh, let's first look at the index and see how we display the name of the person on the listing for the department. As usual, there's going to be two pieces to this. There's going to be what the page model does in terms of retrieving the data, and there's going to be what the CSS HTML page, the Razor page itself, does in terms of displaying the data. So like here, notice what we have. I think I talked about this last time, but if I didn't, or if it's been too long and we want to review it, notice what I'm saying here. Instead of just saying await context departments to list async, I have this include method here. And what that method does is it says to fill in that object in the objects that we're retrieving. So we have our department objects, our department class, that we have a list of these things in there. When we retrieve from the departments entity, we get all these things filled in. But if we want to retrieve this entity and this entity, we want to populate that list, we have to explicitly tell it, hey, go ahead and populate that. If you think about that, that's the most efficient way to do it, because we don't always want the information from the related entities. In this case, for example, we only want information from the administrator or instructor entity. We don't want information from the courses entity, which is also a related entity. That's where this comes in to say, I want the department from the database, and oh yeah, include the administrator data also. So what that will do is that will do a query that actually hits both of those tables. It will pull in the department information, and it will pull in the related instructor for that particular department. So when you want to pull up something from a related entity, you need this include. And this says take the item from the list, and we want to include for that object, we want to fill in the administrator field. That's what this does. This effectively fills in the administrator data for that particular department or departments that we're retrieving. If we look at the display of it then, we say the display from the item, which this is for each item in the model department. What is model department? Model department is a list of, here we go. It's a list of departments. So for each item in that list of departments, we want to display that department, that item's name, budget, start date, and finally want to say the administrator full name. So we filled in that administrator property. Now we want to pull the full name from it. What is full name? Well, if we look in the instructor entity, we have what's called a computed column for full name that takes and concatenates the last name, a comma, and the first name. How do I know it's a computed column? Well, because the get method is not the basic default get method. It'd be really good if you had Java to look at get methods, because you don't have the shortcut in Java. With Java, you explicitly have to write a get method that says, give me the value of this property, and a set method that says set the value of this property. And by default, C# does that for you. And you only have to write a get method, like we do here, if there's more than the default processing. And this is, because this isn't really a property. This is a computed property. All right. In other words, the full name is derived by taking the last name, a comma, and the first name, middle initial, and concatenating it all together. Notice there is no set method for this. There's a get only. That means that we can't change the full name. We can only change the name by changing the first name, middle initial, or by changing the last name. So that's how that gets displayed on there. Now there's only one of these. So that's what we do. We don't loop through them because there's only one instructor. That's sort of a key thing I found in writing code like this. Always be aware if you're talking about one object or a list of objects, because that will tell you what to do. If you have a list of objects, you have to loop through those objects. If you have one object, you can just use it. All right, now the drop down. Again, we're going to look at the page model, and we're going to look at the CSS_HTML page. Let's start with the page model. All right, there's an object that's called a select list object that gives us what we need. All right. What do we need to create a drop down in HTML? We need two things. We need the data that's going to be displayed, and we need the data that's associated with the option attribute, or with the option tag value. Because with a drop down, we show the user something that is meaningful to them. But the database and the entity needs not the name, it needs the ID. So this allows us to create and retrieve a list of IDs and some attribute from this entity. In this case, we're saying from the instructors, we want the ID column, and we want the first mid name column. The ID, the first argument here, or this is actually the second argument, but the first argument after instructors is what we're going to use data-wise in the entity and in the database. Because remember, when we connect things together, whether we're talking about entities or database tables, we connect via primary keys. We don't connect via names or anything like that. We connect via these IDs. So that's what we need to put in the department table, department entity, the ID. But users aren't going to know what the ID is. Which faculty member is ID number 1, ID number 2, who knows? So we want to display something that's meaningful. Now they chose to display only the first name, middle initial. Better would be to display the full name. That computed column that we talked about a minute ago. That consists of a concatenation of the first name or the last name followed by the first name. So that's the first thing I'm going to change about this. Right? Now this select list, that's simply just retrieving the data. Don't worry about this for now, because this is goofy. We're going to change it. This is passing the data to the page using a different technique than what we normally use. For our dropdown, we indicate that we want to select. A select is a dropdown. The dropdown is for the department's instructor ID, and we pull the items from viewbag.instructor ID. What is instructor ID? It's the name of that dropdown that we created. ViewBag and ViewData is a way of passing things. We can pass it using ViewData, and we can then retrieve it using the ViewBag. I don't like that because it's a little inconsistent with how we do other things, and it's confusing. I would rather do this. I would rather say public select list instructor list, or I'll say instructor dropdown. Then I'm going to say instructor dropdown equals new select list from the instructors. Give me the ID and the full name. So we're going to refer to it as an attribute of the model instead of using that view data and view bag to pass stuff back and forth. We then can change this to instructor ID. And why doesn't it like that? Oh. Go. So now we can go here. We can create a new department. And our dropdown shows, lo and behold, full name, so we can know which Roger to pick. Now we're going to have the same code in edit also. It's not a cut and dried rule, but pretty consistently, if you make a change in the one, you need to make the change. If you make a change in the create, you need to make a change in the edit as well. So to be complete, we should go back and change that edit. Now, what are some other things to look at here where we retrieve related data? On the student, when we view the details of the student, we see a list of their courses. Right? So student detail shows a list of the courses. And notice what it shows. It shows the course title and it shows a grade. Let's see if we can figure out what the query is that retrieves this, or what it's going to look like. The student model contains all the information about the student, and it includes a list of enrollments. Those enrollments are the classes that the student is enrolled in. All right. So we're probably going to say that we want underscore context student, and we want to say include enrollments. But if we look at enrollments, each one of those enrollments includes a course ID and grade, but it doesn't include the course name. So we would probably want to say also, we would want to say to then include course name. So let's see if we were right about that. So let's look at the students, details. Okay, and notice the syntax of it. They were pretty much right. A couple of additional things on there that I forgot to mention. That is, we only want one student, so we're using their ID to select them. But from context students, we want to include enrollments. So we want to load up that enrollment list that exists in students. Then I have a then include. Well, what's the difference between then include and include? Then include happens when the related table is related to this one. So if we have an include and a then include, what we're saying is this entity is not related to students, but this entity is related to the last include that we have. So if the course data was related to the student directly, we would simply have include, but it's not. The student is related to the enrollments are related to the course. How do I know that? Here's the students. Student has a list of enrollments. Here's the enrollments. The enrollment has a course. And that course has the course title and so on. So that's why we have this. When we're done, what we're going to have is we're going to have a list of students for which the enrollments list is filled in. We didn't say include, that wouldn't be filled in automatically. We have to explicitly say include enrollments. Likewise, if we just did that, we'd have the students and enrollments, but we wouldn't have any of the course information. We have to go for each of those things in the enrollment entity and fill in the course object. And that's what this does. Again, we're using first to default because we don't want every student. We only want the one that we are viewing. And we get passed in that ID. How are we displaying it? Well, we have our student data here. We then have a loop for every item in model student enrollments to give me, for that enrollment record, give me the course title and give me the grade. We're going to spend more time next week. I have to look at my notes to see for sure what we're going to do. But one of the things we're going to do next week is we're going to look through these different pages to make sure we understand, so we don't think it's just magic that these things get filled in, that we really understand the queries that get called and how the results are used in the Razor page itself to display the necessary. But I wanted to go through a couple of them today just as an introduction. It wouldn't hurt for you between now and next time to study this application and try to understand how different aspects of it work. Run it, look at the results, look what you have, and then go and try to analyze the code that produces them. Any questions at this point? Okay, we'll either see you in lab or we will see you next week. Take care.